Hello, these are just extra videos to help you through the practice problems if you need them. If you don't need them, you can fast forward to whatever problem you need and then just look at that one and then go forth from there. So please make sure you have tried all of these first prior to watching these videos. Okay, so for number 3 through 6, we want to solve this by factoring. So each one is going to use a different method of factoring depending on what quadratic you have given to you. So for number 3 here, we have a number out in front, which means we have to do A times C. We are looking for what multiplies to get 15, but yet adds to get negative 16. The numbers are going to be negative 15 and negative 1. Because of that 3 on the outside, we cannot just write our factors as x minus 15 and x minus 1. That does not work. Okay, anytime you have this number on front, you're going to have to do it with a different method. We're going to use split middle term. So I'm going to rewrite 3x squared. I'm going to split this middle term, this negative 16x, into negative 15x and negative 1x, and then I'm going to bring down the plus 5. So technically, this is the exact same problem that I started with. I just wrote it a different way. So now what I'm going to do is I'm going to break this in half. And I'm going to look for my GCF of my first two terms and my GCF of my next two terms. The first two terms have a 3x in common, so I'm going to pull that 3x out and divide each of them by 3x. So I'm going to be just left with an x for the first term and a minus 5 for the next one when I do 15x divided by 3. The next two don't have anything in common, but I notice that the leading coefficient of the first term is negative 1. So I am going to go ahead and factor out a negative 1. When I divide each term by negative 1, my first term becomes just a positive x. My second term becomes a minus 5. These two factors are the same. That has to happen with this. If it doesn't, the factoring does not work. So since these two factors are the same, one of my overall factors is going to be x minus 5. My other factor is going to be the coefficients that I took out, the 3x minus 1. So this is the factored form. So now in order to solve, I set it equal to 0, each factor, and I solve each of those equations. So my first one, I add 5, I get x equals 5. The next one, I add 1, and then divide by 3. So I get x equals 1/3. So here are my two solutions, and I found them by factoring using split middle term. So for the next one, I'm going to also factor. I'm going to now notice, though, that there are two terms. It's separated by the minus sign, and I can actually square root both of these. So I'm going to use difference of two squares. So what that means is I'm going to go ahead and write down my parentheses right away. I'm going to take the square root of my first term, and it's going to be x. I'm going to take the square root of my last term, and it's going to be a 4. And one's going to have a plus, one's going to have a minus. This method works because when you distribute it, you'd get x squared, and then your middle terms would cancel out, but your last terms would be the negative 16. After I factor it, I'm going to go ahead and set each factor equal to 0. Oops. So it's x plus 4 equals 0 and x minus 4 equals 0. So then you solve for x and you get negative 4 and positive 4. The next one, I notice that I have a leading coefficient of 1. So this one is just going to be my number pairs. So I'm looking for what multiplies to get negative or positive 5 and yet adds to get negative 6. So I'm going to figure out those numbers are negative 5 and negative 1. And so my factors then are going to be x minus 5 and x minus 1. Once again, you can only jump to your factors if there's a leading coefficient of 1 out in front. After it is factored, you're going to set each factor equal to 0 and solve each of those equations. You're going to get x equals a positive 5 and x equals a positive 1. So number 6 here looks the most like number 3, the problem we started off with. So this one has a number out in front. The leading coefficient is not 1. So we're going to have to do a times c. So we are looking for what multiplies to get 4, but yet adds to get negative 5. Our numbers are going to be -4 and -1. So I'm going to rewrite my problem as 2x squared. I'm going to flip my middle term to -4x minus 1x and plus 2. I'm going to split this in half. And the GCF of my first two terms is just a 2x. If I divide that out, I'm left with x minus 2. My GCF of the next two terms is a -1. And if I divide that out, I'm left with x minus 2. These two are the same, so I'm going to factor out x minus 2 as a GCF, and I would be left with 2x minus 1. So that is factored. I'm going to set each factor equal to 0. I'm going to solve it, and I'm going to get x equals 2 and x equals positive 1/2. So that is how we solve with factoring. Let's go ahead and try some of these practice problems with the graphing. So for each of these, you're going to have to try to find your vertex. For number 7, your vertex is going to be kind of nice because it's in vertex form. So it says x minus 5. We're going to flip that, and it's going to become a positive 5 for my x value. That's your h. Your k is whatever it's added at the end, so it's a plus 2, so we're going to leave it alone. We're moving right 5 and up 2. That's our vertex. Then we're going to do the 1, 3, and 5 pattern, but we're going to multiply it by -2. So it's -2, -6, and -10, which means from your vertex, you're going to go over 1. You're always going to go over 1, but this time we're going to go down 2 to get to the next points on each side. From those points, you're going to go over 1, but you're going to go down 6. And then the next ones are off the graph grid, so this is our parabola. So our solutions here are our x-intercepts. So after I've graphed my parabola, I'm going to go ahead and write x equals. And my x-intercepts for this one are where it crosses the x-axis, which happens to be at 3 and 5. For this next one, number 8, I have this. It's actually in standard form and vertex form. You could use it as either. So if we view this as standard form, A is 1, B is 0, and C is -1. So when we do -b over 2a, we get 0 over 2 times 1, which is just 0. So my x value of my vertex is 0. My y value, I can plug in 0 and simplify to get -1. And you'll notice this is also h comma k form. This happens when your x term is missing. So now we're going to do the 1, 3, and 5 pattern to graph our parabola, and we're going to look for our x-intercepts and write them as solutions, which happen to be -1 and +1. Okay, let's try a couple using the quadratic formula. So we're going to do x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And so we have to identify a, b, and c, and then we're going to plug those in. So x equals -b becomes a +2 plus or minus the square root of b squared minus 4ac all over 2 times a. And so we are going to take and simplify everything inside your square roots there. It becomes a +4 minus 20 all over 2. And so we get 2 plus or minus the square root of -16 all over 2, which now we can simplify the square root of a -16. The square root of 16 is 4, but the square root of a negative is I. And so after we have simplified our square root, now we can divide each term by 2. We get 1 plus or minus 2i, and we cannot simplify that farther because we cannot add those two together. One has an I and one does not. Let's go ahead and try the next one. So A is 1, B is 18, C is 80, So we're going to do x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So then if we do this part, the b squared minus 4ac, we can honestly just type those all in our calculator if we'd like to, and we could get that all simplifies to just a 4. Then we can take the square root of 4, which is 2, and now divide each of these by 2. We get negative 9 plus or minus 1. So we're going to do negative 9 plus 1, and we're going to do negative 9 minus 1. So our two solutions are going to be negative 8 and negative 10 when we simplify those. Okay, and then our last two problems here, we're going to solve by taking the square roots. So we're going to go ahead and we're going to get the squared part alone first. Then we're going to go ahead and square root both sides. When we square root, we're going to write plus or minus, and then we're going to simplify whatever we're square rooting. So the square root of 64 is 8, and then the square root of the negative is an I. So we get x equals plus or minus 8i. So we're going to do the same thing for number 12. We're going to get the squared part alone first. So we get x squared equals 20. Then we're going to go ahead and square root both sides. We get x. 20, we're going to take and break down, and we're going to look for number pairs. When we find the number pair, we bring it out. Whatever didn't get paired up stays in, but we multiply them. And we're also going to write the plus or minus, and that would be our final answer. So hopefully this helped. If not, please let me know what your questions are. Thank you.